Welcome everybody. In last class we were starting off with linear algebra and we studied about the Gaussian elimination. So I would be doing in this problem solving session a few questions on Gaussian elimination. I would be utilizing the direct method of elimination for questions in this session. And when I say direct elimination technique, I would refer to utilizing the row elimination technique. Now, after I have completed the row elimination technique, what I would do is I would use the technique of augmented matrix. So these two techniques would be explained in today's class. So without any further delay, let us start off with the first question. We are expected to utilize Gaussian elimination. We have given 2x positive y positive 4z equal to 12, 4x positive 11y negative z equal to 33, 8x negative 3y positive 2z is equal to 20. I will take them as 1, 2, 3 equation, and probably you can refer to them as row 1, row 2 and row 3. Now I am going to be choosing row 1. Now the idea is like this: you actually perform some manipulation on row 1 with row 1 and then add it with row 2 to produce the required row 2, right? So that's going to be the idea. And if you want to start off with row 3, you can perform any manipulations that you require, that you want, and then you add it with row 3, and then that would produce me the row 3. So this is the standard technique that I will be utilizing. Always remember, the operation is going to be addition. So suitably you need to choose the quantity that you wish to multiply with R1, so that that quantity added up with R2 produces us the required elimination. So having mentioned that, let me demonstrate to you. So I'm picking up R1. I will actually add R1 with R2. That would be my first operation. So my plan is to get rid of the first variable quantity that you see here. I want to get rid of this quantity x. So 4 is the coefficient that is occurring with x. So I need to multiply R1 with the negative 2, and then I will add it with R2, and this will produce me my R2. So let me multiply negative 2 with R1. So negative 2 into 2x, that's going to be negative 4x, negative 2y, negative 8z equal to negative 24. My R2 that you see here is 4x positive 11y negative z is equal to 33. Now these two are added together. As I mentioned to you, the operation is always addition. Now negative 4x added with 4x, they both get cancelled. I will get 0. Now 11 added with negative 2, that's going to give me positive 9y. Now negative z added with negative 8z, that's going to give me negative 9z. 33 added with negative 24, that's going to give me positive 9, right? So 9 added with 24 would give me 33, and in this case the operation is, though it is being addition, 24 carries a negative sign. So actually from 33 we say it is addition, but we are removing 24 out. So when we remove 24 out, the value that we are going to get is 9. You know, we will have to be a little bit careful in finding out these additions and subtractions. Okay, so what we have got 9y negative 9z is equal to 9. Now clearly I see a 9, 9, 9, so I can literally divide throughout by 9, and that would give me y negative z is equal to 1. It will not always occur or happen like this, but sometimes when it happens like this, make sure to reduce the system or reduce the equation, and then you write the equation's number. So this is going to be my 4. Since I have named it as 1, 2, 3, this is going to be my 4. Now again what I'm going to do is I'm going to utilize R1. Now if you pick up one particular row, utilize that row to reduce other rows. Don't keep changing the rows. That will result in an ambiguous result. So now what I'm going to do is, I see R3 has got a 8 and R1 has got a 2, so I would multiply. As I mentioned to you, my intention is to get rid of this term, the leading term. So if I were to multiply R1 with negative 4, that would solve me, or that would solve the requirement. So negative 4 multiplied with R1, that is going to be added with my R3, and that would produce the new R3. So let us multiply negative 4 with R1. So that's going to give me negative 8x negative, it's actually 4, right? So negative 4 times 2 is going to be negative 8, and this is going to be negative 4y. So 4 times y, and this is going to be 16z is equal to negative 48, and my R3 is 8x negative 3y followed by 2z is equal to 20. So we have to add. So if you were to add, these two gets cancelled, you get a 0. You add these two, this is going to produce negative 7y, this is going to produce negative 14z, and this is going to produce negative 28. As I mentioned to you, clearly this can be divided by 7. Just divide by 7, and this would give me negative y, negative 2z, and this is negative 4. So this can be taken to be as 5. Now we got 4 and we got 5. So these two can be added. So what I want to do is, I will just take y negative z is equal to 1, and I add it with negative y with negative 2 times z is equal to negative 4. This is going to be straightforward. So these two gets cancelled, I get a 0. Negative 2z added with negative z would give me negative 3z. Negative 4 added with 1 would give me negative 3. So therefore I got 3z, negative 3z is equal to negative 3. So z is equal to negative 3 divided by negative 3. So my value of z is equal to 1. Now if z is equal to 1, you substitute. So let me utilize this part of the page. So substitute z is equal to 1 in 4. I'm going to utilize this. So what happens here? So y negative 1 is equal to 1. So y is equal to 1 positive 1. So therefore y is equal to 2. So I've got two values here. Just by a simple elimination, two values are being extracted. Next I substitute, put y is equal to 2 and z is equal to 1 in 1. So what is my 1? 2x positive y positive 4z is equal to 12. So I'm going to utilize it here. 2 times x positive 2 positive 4 times of 1 is equal to 12. 2 added with 4 would give me 6. So you move the 6 to the other side, you get negative 6. You have 2x is equal to 6. Therefore x is equal to 3. Right? X is equal to 3, y is equal to 2, and z is equal to 1. Now you need to perform the check. That is important. Okay? So check is what? Put x is equal to 3, y is equal to 2, z is equal to 1 in equation 1. I'm going to substitute here. So what happens there? So that's going to be 2 times of 3 positive 2 positive 4 times of 1. This should be equal to 12, right? So 2 times 3 is 6, 2, 4 times 1 is 4 is equal to 12, 6 out of the 2 is 8, 8 out of the 4 is 12, 12 is equal to 12, and therefore you need to write this. Left hand side is equal to right hand side. Okay? Hence the solution is true. You can just add that. So therefore I'm just going to say solution set is equal to 3, 2, 1, and then you can box this. So that completes this Gauss elimination technique for this particular question. So I will also do one more question so that you will be able to understand it better. Okay, so we got another question. X positive y positive z is equal to 6, 2x negative y positive 3z is equal to 14, negative x positive 2y negative z is equal to negative 2. So I'm going to take this as equation 1, 2 and 3, but I will be referring to them as row 1, row 2 and row 3. So we will be performing row operations, and what I observe here is, if I were to take row 1 and I multiply it by negative 2 and I add it with row 2, this would be my new row 2. So that would be the operation I will be carrying it out. So negative 2 times r1. So what would I get? I would get negative 2 times x, negative 2 times y, negative 2 times z is equal to negative 12. And this is added with 2 times x, negative y, positive 3 times z is equal to 14. So you add these two, you get 0. Add these two, you get negative 3y. Add these two, you get a z. You add these two, you get 2. So you cannot do any reduction. So you name this as 4. And next, you clearly see that just by multiplying a negative 1, I don't even have to do any manipulations here. It's straightforward. X and negative x, they can both, when being added, I could easily get rid of this. So now clearly you can see row 3 is negative x and row 1 is just x. So now all I need to do is row 1 added with row 3 will give me row 3. So x positive y positive z is equal to 6. Negative x positive 2y negative z is equal to negative 2. So you add these two, you would get, this goes off, so you get a 0. This is going to be 3y. This also goes off, so you get 0 is equal to 6 added with the negative 2. It's going to be 4. So you have 3y is equal to 4. Therefore y is equal to 4 over 3. Now what you can do is you can substitute this in equation 4. So put y is equal to 4 over 3 in 4. So what is my 4? My 4 is negative 3 times y positive z is equal to 2. So negative 3 of 4 over 3 positive z is equal to 2. So clearly what happens, 3 gets cancelled. So negative 4 positive z is equal to 2. Therefore z is equal to 2 positive 4. So z is equal to 6. Now put z is equal to 6 in the original system. So now what I'm going to do is put y is equal to 4 over 3. Z is equal to 6 in 1. So what is my 1? My 1 is x positive y positive z is equal to 6. Write that down. X positive y positive z is equal to 6. So x has to be found. Y is 4 over 3. My z is 6. So this would mean x positive 4 over 3. Z goes to the other side. I get a negative 6. They get cancelled. So x is equal to negative 4 over 3. Now I need to check. So what I'm going to do, I'm going to check by using equation 3. Right? I'm going to equation 3. So check using 3. So what is that? Negative x positive 2y negative z should be equal to negative 2. So negative x is negative 4 over 3, y is 4 over 3, and my z is 6. This should give me negative 2. So this is going to be 4 over 3, positive 8 over 3, negative 6. Now let me take the LCM. I get 4 positive 8, 3 negative 6. This should be equal to negative 2. This is 12, and 3 can divide 12 4 times. So 4 negative 6 is equal to negative 2. This is going to be negative 2. So clearly this means left hand side is equal to right hand side. So the check is true. So the solution set is going to be negative 4 over 3, positive 4 over 3, and positive 6. So that's the solution for this question. It's a lovely question, and we move on to do the next one. So this is question number 3. I'm going to name them as 1, 2, and 3, and I would be utilizing their names during operations as row 1, row 2, row 3. So foremost, what I wish to do, I would like to, as I mentioned to you, I would take in row 1 and I will perform an arithmetic operation like multiplication or division on them on row 1, and then I'll add it with row 2. Now clearly I see row 2 is x and row 1 is actually going to be, it has a quantity of 3 there. So what I would do is I would have to now select a suitable row. Now if I were to select this particular row 1, R1, then I would have to get rid of this particular quantity 3, and that would really complicate the issue because I will have to divide by 3 and then add it with row 2. So I would alternatively redesign the algorithm. So instead of going and picking R1, I am going to pick my R2 to be the favorable row that would actually be used in the manipulation with the other rows, so that I am able to eliminate the x variable, y variable and reach the z variable. So that is the exact row elimination technique that we would be adopting here. So having mentioned that, what I would do is, as I told you, I've made the choice. This is my row 2 and I will multiply this by -3 and I will add it with row 1 and that would produce me the new row 1. So let's do that. -3 into x, that's going to be -3x, -6y, +3z is equal to -3. And my row 1 is 3x -y positive 2 times z is equal to 7. So we add them. So when you add them, this gets eliminated. This produces -7y. This produces 5z. This produces 4. So this is going to be my equation 4. So now again you pick my R2. Now clearly R2 multiplied with 4, can be added with R3. But the only thing is that I'm going to multiply with -4 and add it with R3. That's going to be my new R3. So -4 times R2, that's going to be -4x, -8y, positive 4z is equal to -4. My R3 is going to be 4x, -y, positive 4z is equal to 13. We add them both. You add, you get, this is going to be 0, this is going to be -9y, this is 8z is equal to 9, right? 9 added with 4 will give you 13, but since it carries a negative sign, it's going to be 9 alone. So this is going to be my 5. Now you see this 4, it has -7. You see this 5, it has -9. So I need to get a component which is common. So what I will do is, I will take 4 and I will multiply it with -9 and then I will add it with 5, but this time I will just multiply it with 7. Fair enough, right? So take 4, you multiply it with -9, that's going to be 63y, -45z is equal to -36. Equation 5 multiply with 7, this is -63y, 56z is equal to 63. Now you add them both, so always we add things. So this will get eliminated. Now 56 and 45, so this is going to give you 1 and this is going to give you 1. Okay, so it's going to be positive 11z and you have 63 and 36, so you subtract them. So 13, this will give you a 7 there, right? Now from 5 you take away 3, you get a 2 there, 27. So 27, okay, let me write it like that. So 11z is equal to 27. So z is equal to 27 divided by 11. Now take this and you substitute it in 4. So put in 4. So what is 4? -7y positive 5z is equal to 4. So -7y positive 5 times 27 over 11 is equal to 4. So you push this to the other side. You get 4 negative. 7 5s are 35, 3, 5 2s are 10, 11, 12, 13 and 11. And this is going to be 44 negative 135 divided by 11. So you have a 135 and take away 44. You get a 1 and you have a 13 and you get a 9 there. So this is going to be negative, right? So this is equal to -91 divided by 11. But you have a -7y, so they become positive. Now 7 divides here 1 time, 2 carry out 13 times. So y is equal to 13 over 11. So I've got that. I've got a value for z, I got a value for y. Now what you need to do is, you take this and you put in 1. I'm going to substitute it here in 2. 2 seems to be simple. So put in 2. So I got a x positive 2 times y is 13 over 11, and my z is 27 over 11, and that should be equal to 1. This is equal to 1. So foremost I take L to be the LCM. This is 26 minus 27 is equal to 1, so that's 1 over 11. So x positive negative 1, so right, negative 1 over 11 is equal to 1. So you push it to the other side, you get x. I'm going to utilize this part of the page. X is equal to 1 positive 1 over 11. That's going to give me 12 over 11. So x is equal to 12 over 11. Now we need to check, right? So put the check here. I'm going to use 1, check in 1. So what is that? 3 times of 12 over 11, and y is 13 over 11, and my z is 27 over 11, and that should give me 7. Okay, so 11 is the LCM. So this is going to be 36, this is going to be 13, this is going to be 54. Okay, so I should produce a 7 there, right? So what happens here? This is 23, right? 36. From 36 you take away 13, that is going to give you 23, right? 3 and 2, 23, and you add 23 with 54. That's going to give you 77, right? 23 with 54. 77 over 11 is equal to 7. So this divides here 7 times. So 7 is equal to 7. So check is true. Check is true. So now you put in the solution. So solution set is equal to x value is 12 over 11, y value is 13 over 11, and my z value is 27 over 11. So this is a beautiful question. It's beautiful question because of the fact that it's not like the way that we had encountered previously. It's all integers, but this one isn't integer, it's fractional in nature. So thank you. We'll move on to the next question. So everybody, in this particular session we will be learning how to solve a system of linear equations in this fashion using Gaussian elimination, and in particular we will be utilizing the matrix method. In matrix method there are two important components you will have to know. One is called as the augmented form, and the other one is called as the row echelon form. So we need to achieve these two forms to get the solution for the system of linear equations. So foremost what I wish to do is I would like to write the augmented matrix. So how do we write the augmented matrix? We will write the augmented matrix by first taking in the coefficients of the variables x, y, z. So the coefficient of x is 1 here, y is 1, and z is negative 1. Then to write the constant term, so this is actually the constant that we see here, negative 2, 5, 1. What we need to do is we need to draw a vertical line like this and then place in the constant. So I am following it up with the other coefficients, 2, negative 1 and 1, constant is 5, negative 1, 2 and 2, the constant is 1. Now this is called as the augmented matrix form. We need to start off with this. Now the idea here is we will have to convert every element below the main diagonal. This is called the main diagonal. Every element below the main diagonal to 0. So I need to have a 0 here, a 0 here, a 0 here. That is the step number, probably I will say 2, because our step number 1 is getting the augmented matrix. So that is going to be step number 1. My step number 2 is bringing or changing all of the elements below the main diagonal. This is called the main diagonal, and all of the elements below the main diagonal should be equal to 0. Now my step number 3 is to achieve the row echelon form. Now what is the row echelon form? the main diagonal elements that you see here should be just ones. The main diagonal should only have 1 in them, and we need to achieve that. We'll perform this operation. Negative 2 times R1 plus R2 will be the new R2. So multiply by negative 2 here, so that's going to be negative 2, negative 2, positive 2, negative 2 with negative 4 will be positive 4, and then place the elements of R2, 2, negative 1, 1 and 5. You add them both, this will give me 0, this will give me negative 3, this will give me 3, and this will give me 9. So write down the new matrix. So I'm going to use this word, new matrix is going to be, place R1 as it is, row 1 remains as it is, so it's going to be 1, 1, negative 1, place that vertical line, and negative 2, and my R2 is 0, negative 3, 3 and 9, and my R3 is negative 1, 2, 2 and 1. Now I would utilize R1, then add it with R3, that would be my new R3, because there isn't any multiplication to be carried out in R1, because you see here you have 1 here, you have negative 1, so add. So let me write down the R1. This is going to be 1, 1, negative 1 and negative 2, and R3 is negative 1, 2 and 2 and 1. You add them both, you get a 0, you have a 3, you get a 1. Negative 2 added with 1 will give me a negative 1. So my new matrix, I'm going to write the new matrix here. The row 1 stays as it is. So 1, 1, negative 1, draw the vertical line, and negative 2. Row 2 is 0, negative 3 and 3 and 9, and my last row 3, or I would say the last row is 0, 3, 1 and negative 1. Okay, we have got that. So now the idea is to make every element below the main diagonal. So this is the main diagonal. Below the main diagonal, every element should be equal to 0. Now clearly I'm going to utilize the sheet. So my idea is to make this as 0. For that I will utilize R2. To R2 I will add R3. That is going to be my new R3. So write down R2. R2 is what? 0, negative 3, 3 and a 9, and my R3 is 0, 3, 1 and negative 1. You add them, you get a 0, 0, you get a 4, you get a 8, right? So let me write down the new matrix. So the new matrix is going to be, R1 stays as it is, right? So 1, 1, negative 1, draw the vertical line, negative 2, and R2 is 0, negative 3, 3 and 9. My R3 is 0, 0, 4 and 8. Okay, so fair enough, we have got that matrix, and the elements below the main diagonal are all 0. Now the problem is not over, because we need to achieve what is called as the row echelon form. And in the row echelon form, the main diagonal elements should all be 1s. So we don't have to do anything with the element, first row, first element, first column element, but we need to actually do something with the second row, second column element. This has to be made as 1. So what I'm going to do is, I'm going to take R2 and I'm going to multiply it with negative 1 over 3. This is going to be my new R2. So let me write down the R2, 0, 1 over 3 with a negative sign multiplied with negative 3. That's going to give me 1. 1 over 3 with a negative sign multiplied with 3. That is going to give me negative 1. And followed by negative 1 over 3 multiplied with 9 will give me negative 3. Okay, so take this and put it in the matrix. Now before that, this 4 should also be made to be as 1. So what I'm going to do, I'm going to put a semicolon and I'm going to multiply 1 over 4 with R3. That is going to give me my new R3. Okay, so I get a 0, 0 and a 1, and this is going to be 2. So let's write the new matrix. So the new matrix is going to be, row 1 stays as it is, so it's going to be 1, 1, negative 1, draw the vertical line, negative 2. So this, write down this 0, 1, negative 1 and negative 3, and write down this, so 0, 0, 1 and 2. Now this is taken to be as the coefficient of x, this is y coefficient of y, this is z, and this is the constant. So what you got here, this represents z. So z is equal to 2, that's the first solution. Now take z is equal to 2 and substitute here. Now what am I doing? I'm just rewriting it as a system of linear equations. So this is going to be also, I can write, this is going to be y negative z is equal to negative 3. Substitute this over here. So y negative 2 is negative 3. Move this over there. You get y is equal to negative 3 positive 2. Therefore y is equal to negative 1. Now substitute all the values in the first row. So put y is equal to negative 1 and y is equal to 2 in row 1. That's going to be x positive, y is negative 1 and z is negative 2, and this is equal to negative 2. So x negative 3, when it goes to the other side, becomes positive 3. So x will be equal to 1. So I've got x is equal to 1, y is equal to negative 1 and z is equal to 2. Now what we can do is, I'm going to perform the check here. Okay, check, put, okay, so put x is equal to 1, y is equal to negative 1 and z is equal to 2 in 3. Okay, suppose I'm taking this say 1, 2 and 3. I'm substituting it in 3. So let me do it over here. Okay, this is 3. So x is 1 and y is negative 1 and my z is 2. So 2 of 2. So that should give me 1. So this is negative 1, positive of negative, that's going to be negative 2, positive 4. Negative 3 added with 4 will give me 1. So this gives me 1 is equal to 1. So left hand side is equal to right hand side. So the solution is absolutely correct. So therefore the solution set is 1 comma negative 1 comma 2. Okay, so probably you can box it. So this is a lovely question, and we have adopted the technique of matrix methods by solving. We'll move on to the next question. Okay, we've been given this question: 2x positive y negative z is equal to 1, 3x positive 2y positive z is equal to 10, 2x negative y positive 2z is equal to 6. Now foremost we need to write the augmented matrix, and that is going to be, write down the coefficients of x, y and z, 2, 1, negative 1, draw a vertical line, place the constant there, followed up by 3, 2, 1, place the constant, and 2, negative 1 and 2 and 6. So this is what we have got. Now as I have mentioned, this is the main diagonal. Okay, now everything below the main diagonal should be made to be equal to 0. So this has to become 0, this has to become 0, and this has to become 0. Okay, that is our first step after getting the augmented matrix. Now for that, what I'm going to do is, I would be utilizing the first row, row 1, and I will multiply it by negative 3, and then I will add it with 2 times of row 2, which would give me my new row 2. Okay, so let me write down row 1 after multiplying it with negative 3. So it's going to be negative 6, negative 3 and positive 3 and negative 3. Now row 2 multiplied with 2, that's going to give me 6, 4, 2 and 20. Now we add them both. This will be 0, this will give me 1, this is 5, this is 17. So now the new matrix, this is the new matrix. Row 1 stays as it is. So it's going to be 2, 1, negative 1, draw the vertical line, and 1. This is row 2, 0, 1, 5 and 17. And row 3 is 2, negative 1, 2 and 6. Okay, so now what I wish to do is I would like to multiply row 1 with negative 1 added with row 3. That is going to give me my new row 3. So let me do that. Negative 2, negative 1, positive 1, negative 1. Row 3 is 2, negative 1 and 2 and 6. So we add both the things. I get a 0, negative 2, 3 and 5. So my new matrix, so let me use this paper. So this is going to be my new matrix. So new matrix is row 1 stays as it is, 1, 2, 1, negative 1, draw the vertical line, 1, 0, 1, 5 and 17, and this row 3 0, negative 2, 3 and 5. Okay, fair enough. Now what are we going to do is we have achieved these two elements to be 0. Now this should also be made to be as 0. So for that, what I'm going to do is I'm going to utilize row 2. So 2 times of row 2 added with row 3 is going to give me my new row 3. So 2 times 0 is 0, 2, 10, 34 and 0, negative 2, 3 and 5. So add them both, you get a 0, 0, 13 and this is going to be 39. So now my new matrix is going to be, write the row 1, 2, 1, negative 1 and 1, 0, 1, 5 and 17, 0, 0, 13 and 39. Okay, now what we need to do is we need to get the matrix in the row echelon form. For that, the main diagonal should be equal to 1. All of the elements should be equal to 1. So to achieve that, I'm going to divide or multiply row 1 by 1 over 2, and that's going to give me my new row 1. So when I do that, I get 1 over 2, negative 1 over 2 and 1 over 2. Now row 2 you don't have to do anything, it's already 1, so just write down that matrix. Now row 3 you need to divide or multiply by 1 over 13. So 1 over 13 times row 3 will be my new row 3. So 0, 0, 1 over 13, 1, 1 over 13 times 39, that's going to be 3. Okay, so we have achieved the row echelon form. Now this is the x coordinate, y coordinate, z coordinate. So what do you have? Z is equal to 3. Now rewriting it into the linear system, we now have y, also I can write it like this, also y positive 5 times z is equal to 17. So my z is 3, so y is equal to 17 minus 15, which means y is equal to 2. And from the first row, what do we get? X positive y over 2 negative z over 2 is equal to 1 over 2. Now y is 2, so this is going to be 1, so push this 1 to the other side. You get x negative z over 2. When 1 goes to the other side, negative 1, that's going to give me negative 1 over 2. And my z is 3, so x is going to be 3 over 2 with a negative sign. It will become positive 3 over 2, negative 1 over 2. This would mean x is equal to 1. Okay, now you can perform the check. I'm going to perform the check here to show you. So 2 times x is 1, y is 2, and z is 3. This should give me 1. So I add these two things, I get negative 1. This is 2 negative 1 will give me 1. 1 is equal to 1. So left hand side is equal to right hand side. So the solution set is what? X is 1, y is 2 and z is 3, right? 1, 1, 2 and 3. So that completes our Gauss elimination involving 3 variables. So far we have done 3 variables. In the next class I'll show you how to handle questions with 4 variables. Thank you everybody. Please like, share and subscribe.